Alright, so here we are with our 4-5 triangle congruence, side, 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 and side angle side notes. That's what these stand for. We'll get to that. So we're going to apply these to construct triangles and solve problems as well as prove them by using these. So, first thing that we want to double check is that eventually in our vocabulary we're going to talk about an included angle, so just thinking about what included would mean. So, our first postulate is the side-side-side congruence, and this can go in your reasons packet as well. So, the idea of side-side-side, or SSS, anytime you see an S, we're talking about a side. Anytime you see an A, it's going to be angle. Is that if you happen to have three sides of one triangle congruent to three sides of another triangle, then those triangles are congruent. So, basically, this is a shortcut. Okay, because previously what we've had to do is also say that every single angle matched up and was congruent. But now we don't have to do that every single time. Okay, so basically it's a shortcut that skips angles. What happens is if you have three, for instance, I don't know, different lengths of popsicle sticks or something, if you try to put those three popsicle sticks together to make a triangle, you can never actually do it. No matter how much you flip or rotate or whatever, you will not actually make another triangle. It will always be this triangle with three of the same sides, which will always have to end up having the same angles. So, again, this is our shortcut. It skips angles. It's very exciting. So if you have all three sides matching, awesome. You can use side, side, side to say that everything is congruent without having to think anything of the angles. So, our next piece here is just to remember that adjacent triangles share a side. So you can apply the reflexive property to get a pair of congruent parts. So for instance, if you happen to have a triangle or set of triangles like the ones here, if you're trying to say, well, this one was given and this one and this one and this one, well, how do I know that that one's the same? Well, of course it's the same because they share it. And so then you can use the reflexive property and just say AB, for instance, is congruent to AB by the reflexive property. Alright, so moving on, we also want to talk about an included angle. So this was that vocabulary there. An included angle means that it's an angle that's formed by those two adjacent sides. So if you're talking about AB, this side, and BC, this side, angle B is the included angle. Alright, so in that case, again, I like to think of it as like what two sides surround the angle or make up the angle, because of course an angle is always made by two rays or two lines, and so of course those are the two segments that make it up then. Alright, so just for our definition here, an included angle is an angle formed by two adjacent sides, again they come one right after another, of a polygon. And as I've said, or in the diagram, you can see that angle B is the included angle between this side of AB and BC, right here. Alright, that is important because now in our next definition of side angle side, so notice we have an A instead of an S in the middle. When you have that A there in the middle, we're now talking about two sides surrounding that included angle, and those match. So again, this is just another shortcut. Because what happens if you don't have all three sides, but you do happen to have an included angle? Well, now, based on this theorem, you can say that those two triangles are congruent, and you can skip the other side and the other two angles. So, again, looking at our definition, if two sides and the included angle of one triangle, so here's the two sides and the included angle in one triangle, are congruent to two sides and the included angle of another triangle, so two sides and included angle, then the triangles get to skip to being congruent. So you get to, again, miss out on this side and these two angles. Again, this is because if you take those two toothpicks or whatever lengths of objects you have, if you have two of them, like two different size pencils, you put them together at a certain angle, the only triangle that you can make that connects the endpoints of those two segments is always going to be the same. So this two lengths and this angle kind of force only one triangle to ever actually work. Alright, so we will go ahead and get to our caution here. The letters SAS are written in that order because the congruent angles must be between the pair of congruent sides. So, again, this angle is not the one that we are going to be talking about, and neither is this one when we talk about side angle side. Because again, it needs to be the side and the side that surround this angle. Alright, otherwise we have a different proof, which we're not to yet. Alright. So, we're going to do a few proofs here just to kind of see if we can get through this. So, you'll notice here, for instance, in our proof that they are trying to get you to do side angle side. Alright, so as I can see, I have one side, right, on here, so BC and AD, so that's right here, that are given as being congruent. And then I also have this set of parallel lines, which remember usually leads to angles, like alternate interior, alternate exterior, corresponding, that kind of idea. So, we're going to go ahead and start our given. So I'm just going to re-copy. It looks like there's two sections for the given. So I'm going to do the BC parallel to AD first. And then I'll write the BC segment congruent to AD. Alright, so now that we have those two pieces, notice that they're telling us alternate interior angles. And we said that those parallel lines usually lead to some sort of angle pairs. So taking a look at what is parallel, we've said this line and this line are parallel. And so as you can see, there's this transversal that's going through here. So if I'm going to find some alternate interior angles, that would be this angle here and this angle here. Sorry, I drew it really sloppily, so it didn't really make an angle that made sense. So this angle here. So that means that we actually have angle, this one up here, CBD, and that's going to be congruent to angle ADB over here. Alright, so going back to our original image here, without all the scribbles, we now have that this angle and this angle are congruent. Alright. We are also given that BC and AD are the same, and then they're asking us to look at the reflexive property. So remember, reflexive property, as we saw in our, where was it here? In our remember, the reflexive property is because we happen to share a side. So looking at this image that we have, this side is shared. So it turns out that we're going to say that BD is congruent to BD by the reflexive property. Now taking a look at what we have, we've now built up an angle, a side, and a side. The only thing we need to check is that that angle is actually between the two sides, and so if I think this side and this side is the angle between them, yes. And then this side and this side is the angle between them, yes. So if it was this angle, for instance, or this one, we would not have side angle side. So now we can say that the two triangles are congruent. But of course we want to do it in a way that will be in the order that we want, okay? So I can't just say however I want ABC or something like that. I do have to, for this triangle, if I start along the side that I've said was congruent originally, AD, and then go to the angle that we just found, so AD and then B, I have to do it in that same order for the next triangle. So I have to go along that side that was originally given, CB, go to the angle that we found, which was B, and then go along to D, so CBD. So just always make sure that once you are done, that the things that you said were congruent to begin with are congruent. So for instance, BC being those first two letters are going to be in that same order or in equal to AD, the second two letters. So be careful. Alright, this next one here, we have QP is bisecting angle RQS. So QP and RQS. So basically they're going to say that this angle and this angle are the same. And so we're going to use the definition of bisecting. Alright, we're also given that QR and QS are the same, so that's those tick marks that are there. And so we have to prove that this left triangle and right triangle are going to be congruent. So, taking a look at what we have, QR and QS, that's a side being congruent, and that is given. They're also telling us QP bisects angle QRS, and that's given as well. And then we're going to come up with an angle. So this angle is RQP. Let's see, RQP, that's this left angle. And the fact that it's congruent to this right angle, and that is what we had before, which was definition of bisect. Because again, this line kind of cut it in half. Alright, then they're going to say that QP is congruent to QP, which is another side, and that's going to then be by the reflexive property. Because, again, notice that those are the same letters. So now we have two sides and an angle, and so we're probably going to end up using side, angle, side, but just to double check, we want to make sure that that angle is surrounded by the two sides. So again, side 1 and side 2, yep, they surround that one. And side 1 and side 2, yeah, they surround that one. So just to make sure that we're clear about if it actually works. Later on we'll be using other pieces, so we want to make sure that it's side, angle, side and not a different proof. Alright, and then our last proof here, again just walking through what they give you, they're telling you that PN bisects MO. I think these are kind of moved over, they're supposed to be over here. Anyway, yay converting documents. So PN here is bisecting MO, so that's different than what we had before, which was an angle. So, by the definition of bisecting, we're probably going to be able to say that MN and NO are congruent. Alright, the next thing they tell you is that PN is perpendicular to MO, and so that probably means that we're going to get some right angles, or 90-degree angles, okay? But again, we're going to have to use this definition of right angles or perpendicular in order to actually get there, which is what I'm seeing right here. So, filling in our proof, they want, notice that this is a book proof, so they're giving us two givens. And since this one says definition of bisect after it, I'm probably going to write that PN bisects MO first. And then the other given, which was PO is perpendicular to MO, is going to be next. Alright, so by the definition of bisecting, as we saw up here, MN is going to be congruent to NO. So let's write that, MN congruent to NO. And so that's one of your sides. Let's see, the next piece is going through the reflexive property, so that means we look for that side that's shared. So PN is congruent to PN, and that's another side. And then we get that PO and MO are perpendicular. And so by the definition of things being perpendicular, we now get to say that angle MNP and angle MNP and ONP are right angles. Then looking at the right angle congruence theorem, if we have two things that are right angles, then they are congruent to each other because there's no other degree that's in there. So MNP is congruent to ONP, which gives us now an angle. So the only thing we need to do is double check that that angle that we just talked about is between the two sides that we've mentioned, and they are. So here's our side, and our angle between. And so by side, angle, side, we are now able to say that two triangles are congruent. So, for instance, if we start at P, P to N to M is our triangle. And that's going to be congruent in the same order from P to N, but now to O. Alright, so those are our proofs, and kind of going over side, angle, side. There wasn't a side, side, side proof, but there will be on your homework. So You'll just, instead of finding an angle, you'll find another side. Don't forget to fill in your reasons packet, either now with the notes, since we don't have a lot on notes days, or you can go ahead and do it as you're doing your assignment. And on HeadRush there is a link to a filled in packet, so you can kind of see how I would do it.